Welcome all in the lecture of Fourier transform. Let us first define what is meant by a Fourier transform is. Fourier transform is basically an integral transform which takes you from the time domain to the frequency domain. For that, sometimes it's possible your functions which is in time domain are discontinuous. We transform it into a frequency domain and we get a continuity about it. So basically, what is the requirement to get a Fourier transform of any function is a function f of x is to be defined in the interval minus infinity to plus infinity, and it should be a piecewise. It should be a piecewise continuous on this interval, continuous on finite intervals. It should be a piecewise continuous on the finite interval, and it should be an absolutely integrable function on the same interval, that is minus infinity to plus infinity. Then the integral given as 1 upon square root 2 pi integration from minus infinity to plus infinity f of x into e raised to r s x dx. If it exists, then it is called as a Fourier transform of the function f of x, and it is denoted by capital F of s. And it is denoted by capital F of s. So you can remember this definition of the Fourier transform. Now, we are going to discuss a problem from university examination to find the Fourier transform of the function f of x is equal to e raised to minus x square by 2. F of x is equal to e raised to minus x square by 2. We know that capital F of s is equal to 1 upon square root 2 pi integration from minus infinity to plus infinity. Here I get f of x into e raised to I s x dx. This is the formula of the Fourier transform. So using this, we are interested to work out the Fourier transform of f of x is equal to e raised to minus x square upon 2. Now, this is equals to 1 upon square root 2 pi. As they are not specified the interval for this function, we already understood that it is defined over the interval minus infinity to plus infinity. E raised to minus x square by 2 into e raised to I s x dx, which gives us 1 upon square root 2 pi integration from minus infinity to plus infinity e raised to minus x square upon 2 plus I s x dx. Now just look at the numerator of the, sorry, not a numerator, power of the exponential term. X square is present as well as x raised to 1 is present. So in 7th standard we have seen the concept of how to make a perfect square of the given polynomial. So using that concept, I can write this particular term as 1 upon square root 2 pi integration from minus infinity to plus infinity e raised to minus 1 by 2 into bracket x minus is square into e raised to minus s square by 2 dx. By making a perfect square in the numerator, we get these two terms, which therefore this is nothing but 1 upon square root 2 pi e raised to minus s square by 2 is a constant taken outside integration from minus infinity to plus infinity e raised to minus 1 by 2 into x minus is square dx. To evaluate this integral, we make a substitution. Put 1 upon root 2 into x minus is equal to y. We are making the substitution. Put 1 upon root 2 into x minus is equal to y. Therefore, differentiating on both sides, we get dx is equal to root 2 into dy. So hence my integral becomes, the f of x becomes 1 upon root 2 pi e raised to minus s square upon integration from minus infinity to plus infinity, this term is now replaced by y. This is minus 1 by 2. We are taking here 1 upon root 2. Hence it becomes e raised to minus y square. And dx is replaced by root 2 into dy. Dx is replaced by root 2 into dy. Now, in semester 1 we have seen the concept of the gamma function. We can reduce this into a gamma function. Because of that, the value of this integral is, this is a well-known example from there. So I will write the standard value of this directly, s square by 2 into root pi. Okay, this root 2 will be taken outside into root 2. So root 2 will cancel, root pi will also getting cancelled, e raised to minus x square by 2. So the Fourier transform of e raised to minus x square by 2 is e raised to minus a square by 2. In the next lecture, we are going to deal with the inverse of the Fourier transform. That is, this is from we are transform x to s, and in inverse Fourier, we are going to shift from s to x again.